Hello everyone, my name is Faisal Al-Humaidi and today I'm going to talk about manufacturing of a wind turbine blade. A turbine basically converts the mechanical rotation into electrical power. Wind turbine design is the process of defining the specifications of a wind turbine to extract energy from the wind. A wind turbine installation consists of the necessary systems needed to capture the wind's energy. There are basically two types of wind turbine: horizontal axis wind turbine and vertical axis wind turbine. So here's the pictures of the horizontal axis wind turbine and the vertical axis wind turbine, but the most used one is the horizontal one because it's more efficient. Design of a complete wind power system must also address design of the hub, generator, supporting structure and foundation. Modern wind turbines are designed to spin at varying speed. In contrast, older style wind turbines were used with heavier steel blades which have higher inertia. The high inertia buffered the change in rotation speed and thus made power output are more stable. So blade design. Here's a picture of a tip of unpainted blade and one blade turbine test. So the primary objective of the designer is to maximize the aerodynamics efficiency. Also, the objective should have two major points: mechanical criteria and economical aspects. The number of blades is selected for aerodynamic efficiency, components, cost, and system reliability. Noise emissions are affected by the location of the blades upwind or downwind of the tower and the speed of the rotor. A small increase in tip speed can make a large difference. A wind turbine developed over the last 50 years have almost universally used either two or three. So here's a picture of two blade turbine and three blade turbine, but the three blade turbine has 3% more efficiency than the two blade turbine. So that's why it's the most efficient one. But if you compare the three blade turbine by the four blade turbine, the four blade turbine has only 0.5% more efficiency than the three blade turbine. So if you compare the cost by the efficiency, it's not that worth. That's why the three blade turbine is the most used one. In general, ideal materials should meet the following criteria: wide availability and easy processing to reduce cost and maintenance, low weight or density to reduce gravitational forces, high fatigue resistance to withstand cyclic loading, high fracture toughness, the ability to withstand environmental impacts such as lightning strikes, humidity, and temperature. So here is the manufacturing methods for the wind turbine. Vacuum assisted resins transfer molding is an open-top mold composite part fabricating method that attaches a vacuum bag to the top of the mold tool and applies vacuum to assist the flow of infused resin from one side of the mold to the other. Resin transfer molding uses a liquid thermostat resin to stature a vapor preform placed in a closed mold. Open molding is a low-cost and effective method to manufacture composites. Open mold process includes spray-up and hand lay-up. So here's a picture of vacuum-assisted resin transfer molding. You can see there's a vacuum in the end of the process that will pull the material out, and this process has ability to create large complex parts with low cost. RTM products typically contain a fiber load of 25 to 50%, making them light with good strength to weight ratio. It also can produce extreme complex geometric shapes regardless of the size. And here's the open mold. The open mold is the less expensive one because it requires the least amount of equipment. Composites for the wind turbine blades. We have the glass and carbon fibers, aramid and basalt fibers, natural fibers, thermosets, thermoplastics, nano-engineered polymers, and composites. Here exists a few general methods for recycling wind turbine blades. Mechanical recycling. This method doesn't recover individual fibers. Initial process involve shredding, crushing, or milling. The crushed, the crushed pieces are then separated into fiber-rich and resin-rich fractions. For the chemical processing, the material is heated up to 500 Celsius in an environment without oxygen, thus cause it to break down into lower weight organic substances and gaseous products. Direct structure recycling of composites, developed to combat the inefficiencies and cost associated with chemical, thermal, and mechanical recycling processes, which either reduce the performance properties or only act as filler for other composites. And thank you very much.